Hello, everyone. So this talk is about Mu, which is an emulator like Mame. And it was like an excuse for us to work together because we both love fighting games, especially retro fighting games 2D. I specifically love Super Street Fighter 2X or 2 Turbo, and he is a player of all 2D fighting games. Yeah. So he can play everything. I can only play Street Fighter. But we fight each other quite a lot, and we also happen to both like reverse engineering and radar. So I am Pau Oliva, from Twitter known as POF. I work at Synacktiv as a senior security consultant, and I do a lot of pen tests, reverse engineering, this kind of work. And yeah, I only play and care about Super Street Fighter 2X.
Okay. Yeah, okay. So my name is Nico. I'm working in a French company that is called Synacktiv. So this company is focused on offensive security. There are 3 teams: pen test, reverse engineering, development. And I'm on the reverse engineering team. Like what we do every day, it's low-level development, reverse, and vulnerability research. Okay, so today we'll talk about what we did on the game Street Fighter Sochi Anniversary Collection. This game was released last year on every platforms like PC, PS4, Xbox One, and Switch. It was developed by Digital Eclipse and edited by Capcom. Okay, so on that collection, you can play 12 different Street Fighter games. So it's all the classical ones like Street Fighter 2, Street Fighter Alpha, and Street Fighter 3. And the good thing is that you can also play online, but you can only play like limited games, like 4 games online. There is also a training mode when you can practice your combo. There is a museum, like you can see, you can have like, you can read facts about the making of all Street Fighter games. So actually the game is great, like everything is nice, but it's a bit sad that we can only play 12 games offline and just 4 games online. So we thought it would be cool if we could like maybe play more games. So, Digital Eclipse, it's a company, video game company, that is used to port old games to new platforms. And in several games, they use a custom emulator that is called Mu. So they use it in Street Fighter Anniversary Collection. They use it in a compilation of old SNK games and in a new game that will be released maybe next year, Samurai Shodown Collection. So in the beginning, we didn't know that. Like, when we begin the reverse, we use a lot of bin diffing tools like BinDiff, Diafola, Pegasus, etc., with open source arcade emulator like Mame to know if they use like code from classical emulator. But there was absolutely no hits. Like it seems they really wrote it from scratch. So what we want to do? What we want to achieve is, well, to understand how the emulator works to play more games. We want to fix some bugs, and we want to maybe play games using the online from Capcom. It will be good. So why we do that? Because there is like, as we said, there is a Mame emulator, and it works well actually. So why we want to bother doing all that? Well, we noticed when we are playing that Mu actually works pretty well with some games, like Third Strike is running much better in Mu than in other emulators. And there is an online mode that is provided natively, and it works really well. So Mu, we always say Mu, but where it comes from? Well, actually, when we are looking at the classes names, there is the the name Mu that it appears at several classes name, like Mu CPS2, Mu CPS3, etc., etc. So what we did is we Google it to know if there is something known about that emulator, and actually there is only one occurrence that is useful about that emulator. It's a guy that talked about Arcade 1-Up in Reddit. So Arcade 1-Up, it's a cheap cabinet, arcade cabinet, okay? And the guy said that it's using an emulator that is called Mu, a commercial emulator, and he says something interesting. He said it's hard-coded to support only a specific small number of ROMs, and it's exactly the case for Street Fighter Collection. So yeah, it costs $350, and for example, on that model, you can only play 3 Street Fighter games. There are other models, like if you want to play Final Fight, you will have to spend again $250 to play just Final Fight. Well, the good thing is if you want to analyze like the ROM, you don't have to buy the whole arcade cabinet, you can only buy the PCB. And when you extract the ROM from the PCB, you can run a strings command on the ROM, and you can see that there's a motif Mu again that it appears. And we can see that there are classes named Mu CPS2 that are similar to what we have in Street Fighter Collection. So yeah, actually it uses an emulator, Mu. It's the same emulator. So now we want to dig more, like we want to know who wrote that emulator. So when we are reversing the ROM, here, we saw a copyright, Daniel Filner. If you look at Google, Daniel Filner, it's a guy that has more than 30 years of experience, like developing. Like this guy, like literally was porting games at the past, like during Atari ST. And you can see that he was emulation engineer for the game, Street Fighter Collection. Okay.
So we thought it would be cool to take games from Mu and be able to run them on a real arcade cabinet. So initially I thought, okay, that will be easy and quick. So the main motivation, you know that I only play Super Street Fighter 2 Turbo. So my main focus was this game. And when the 30th anniversary collection was released, Capcom or Digital Eclipse, I don't know, they promised that there would be arcade perfect gameplay. That is that they are running the actual arcade code, the same ROMs that you use in a real hardware. But they said that they would fix any glitch or bug that causes the game to freeze or reset. So actually, this is half true, because they did that, for example, for Third Strike. Darksoft has recently released a version dumped from the patch that they do in 30th anniversary. So in the Street Fighter 3 Third Strike, they actually did that. But for my game, for Super Turbo, they didn't. So first I checked if there is one glitch that freezes the game, is if you take old Honda, the old version of Honda, it's the version from the Super Street Fighter, and you do a throw in the corner, it's stuck, and then when you have to wait until the time is over, and when it time's over, it's stuck forever in there. So you have to actually reset the emulator or the real hardware. So this is an example of this glitch. So you can see now that he's going to throw, and now the other guy is moving, but the timer is going down, but old Honda is stuck there. cannot do anything. It doesn't react to controls or anything. So if we move that forward a little bit, you see that the time is over, and the machine just it's stuck in there. So this is the glitch that hangs the game, and there is another glitch which resets the board, the game board, which is if you play against the Zangief CPU and you do a tiger knee using Sagat, it will reset the board. So this is actually on the 30th anniversary collection, and now Sagat will do the tiger knee, and you see, oh, the game is starting. And here, let me pause it here. So here is the interesting thing. So when the game resets, so in the 30th anniversary collection, when you play, you don't see the game booting. When you start playing, you start in the player selection screen, so you don't get to see this screen. And when I saw this the first time, I was like, what the fuck? Is 940323. So the game, the board that I have, the actual game, my version is 940223. So this is 1 month after. So this was the main motivation for me to dump this. So you can see here, this is the world version, Super Street Fighter 2 Turbo, with the 94. This is released in 1994, February 23. The USA version, which is the same one that is included in the 30th anniversary, which is a month older, and the Japanese version 2X, which is as well 0223. And then the screenshot that you saw, the 30th anniversary, which is 03. So the main motivation was to get a possibly undamped ROM. So the quickest thing to do for me was just to write a quick shell script that will get the assets from the game, extract the audio. So basically, I just looked with a radar, the X, compare, looked that it was the same. So I just used DD to split the file in two. So the audio CPU in Mame or in the game board, there are two ROMs. In Mame, it's 2 files. And in the Mu, it's just 1 file. But if you split it in half, you get the 2 files, same SH1, so easy. For the audio samples, it was literally the same thing, split the 2 files. And then for the actual code, the code that runs on the main CPU, on the Motorola 68K, this was a little bit different. So Mu runs you probably know from before that CPS2 has encryption, and the key is on a RAM memory on the board, and there is a battery that keeps the RAM powered on. And if this battery dies, the board is suicided, so you cannot use it anymore. So that's why you have to change the battery every 10 years to make sure that your board will be alive. So in Mu, they removed the encryption. So if you actually want to run this on a Mame, you have to re-encrypt it with the proper key. So Radar has support for CPS2 encryption with Rahash. So we actually split the file in pieces and use Rahash to re-encrypt the pieces with the CPS2 key that is used in this game. And so far, so good. Everything matched. Like we do the compare SH1, and everything was good. But then it comes the big pain in the ass, which is the graphics. So converting everything from Mu to Mame, or Mame to Mu, was easy, but the graphics were not that easy. This is the intro of the game. This is the Ryu silhouette and the insert coin message. The Ryu when the thunder splashes, so it's more clear. And this is actually this is Guile, and this is Ken, the life bar, timer, super bar. So you can see that something is there, but it's not really like it should look. So after I get to this point, I got really demotivated because I started to look at the main sources, and I noticed that the game that was in there was not undamped. It was already damped, and Mame already had it. So I was so disappointed with that. And the only change, so I was expecting like the glitches fix it or something, but no. The only change is Alt Dictator, the standing fierce punch, has a sprite, a glitch in this sprite. So this is in the old version of the game, and this is in the 1 month newer that they fixed this sprite. So it was a big disappointment, but yeah, I still wanted to like for fun, burn the game and run it on a real hardware. So took a B board that was dead, no battery, and then I used Andem CPS2 InfiniKey, which is a little piece of hardware that you solder into the board. Mickey, where are you? This guy soldered into my board the InfiniKey, and you program. These are like jumpers, so you program the key of the game in these jumpers. And what this does is this injects the key, the security key, on the RAM when the board boots. So you bypass the need for having a battery on the board, so this board will last forever. No suicide anymore. And it runs the actual ROMs because you don't have to burn decrypted ROMs or anything. It runs the real ones. So I bought the EPROMs, AliExpress, and cheap ones. Then EPROM programmer burn them and try, but the graphics are still shit. I still have not been able to fix. And someone asked me to put this slide on the presentation, so here it is. Graphic conversion is a pain in the ass, and I thought, I'm sure the night before the presentation I will be able to fix that and show them the photo of the cabinet running with proper graphics. But the night before we were in a bar drinking until 4:30. So today we have bad graphics. Now, Nico.
Okay, so now we'll show if it's possible to play more games using Street Fighter Collection. Okay, so in order to do that, when we were analyzing the game, we are looking at the workflow, what happens when we choose a game on the menu. So what happens is there are a game object. For example, if I choose Street Fighter 2 Hyper Fighting, there is an object, game Street Fighter 2 Hyper Fighting, that is initialized, and actually this game is running on CPS1, so it's inherited from a class that is called Mu C CPS1 that inherits to Mu base that contains like specific configuration for CPS1. So after initializing all these objects, what it does is it gets the game assets that it needs from the file system, for example, the worms, the logo files, etc. It will map the graphics using bank mappers in memory. It will render the graphics and run an emulator to execute the main game CPU, so the code from the game, the executable code. Okay, so the game assets. There are a lot of embedded files. All the assets are located inside these files. These resources are neither compressed, they are not encrypted. There is a French guy that is called Loïc Petit. He wrote a script to extract all these assets. So by extracting the game assets, we can get to the ROMs. And we noticed that it's not so easy. Like, we cannot just download a ROM from Mame and replace the assets directly, because Mu, it works only with plain ROM. Okay. So the first thing we have to do is we have to write a script to convert any ROM from Mame to Mu. So we'll show how we can do it. So we take, for example, Street Fighter 2 Hyper Fighting. So in Mu, it's composed of 4 files, and in Mame, it's more files, several files. So there is a main CPU code here, and there is a graphics files, audio samples, and audio CPU. So what we have to do is to convert all these files into these files, okay? So for the main CPU, it's kind of easy, because we can spot the differences like just with the eye. For example, here we can see COB00, and on the other side, 00COB. Actually, just there's a swapping of each 2 bytes. And actually, if you check the Mame CPS1 driver source code, you will see there is a place where it shows how to load each data in memory. And we can see word swap. So for the main CPU, we could just look at this driver source code to know how to load it. Okay, so for the audio samples, it's easy. You just have to concatenate the files, and yeah, that's it. So you will need, with our Python script, we'll need to parse the CPS1 driver source code to know to concatenate in the correct order all the files. For the audio CPU, it's the same. It's easy. We calculate a SHA-1 and we see that it's the same file. For the GFX, it's a bit more complicated, but it's okay. On the Mu part, we saw that the name was something.vrom. Actually, the VROM is one chip that is located inside the game board, and it contains all the metadata for assembling the tiles. So there is 2 steps. We have to merge each file into one, reorder the bytes, and decode the GFX data. So for the first thing, it's not so easy to see from the eyes, but after looking at the Mame source code and doing a bit of reverse, we can notice that each 4 files of Mame, actually it's loaded in the 2 first columns. So that is the way to reorder the bytes. And after, for the decoding of the graphics, well, we just rip the function from the Mame source code. Okay. So as I said before, we need to parse the Mame driver source code. So when I run my Python script, and actually my Python script will produce a lot of rom dot something, and the original files for Mu was Street Fighter 2 dot something. Okay, if you look at the hashes, we can see that we're okay. Everything is identical except the VROM, the graphics. So you can say, your tool doesn't work. Actually, you are bullshitting us. But actually no, because when I replaced the asset with these files, it was actually working. So we are what the fuck? Why does it work? Why it's not the same hash? Actually, it's just stupid. It's just that the guy from Street Fighter Collection, they patch a graphic element in the stage of guy. That is the original arcade one, and that is from Street Fighter Collection. That's why we don't have exactly the same arch.
And the Hong Kong flag
and the
is
Hong Kong flag
also changed.
So yeah. Okay, so now we are good. We can convert any CPS1 ROM from Mame to Mu. The next step is to force the game to load our converted ROMs. So 2 steps. We have to locate the assets loading function, and we have to hijack the execution flow. So the function for asset loadings, actually there is a class that is called bundle file system. And well, it's a class that is used to parse all the bundle files. In the beginning, what we can see here, actually it's easy, just like get the data of the correct file where the asset is located. That is more important for us. There is a function that we rename getField. Actually, it takes the size of the asset, of the needed asset, okay? Then it takes the offset, because the offset will say, okay, this asset is located at that place in the file. Then it allocates space with the size, and it gets the data and copies the data in the buffer. So what we have to do is we have to hook to replace the resource with our resource. So we have to hook at 2 places. We have to use hook inline because we want to hook at not at the beginning of the function, but at whatever address. We have to hook at here, at that place, because we want to modify the results of getField. Because if our asset is like bigger than the original asset, we have to change the size. And then we have to put a hook here after getData to patch the original data with the new ones. So in order to do that, because we are lazy, we use VEH hooking. Sorry guys, I'm a Windows guy, so yeah. And actually VEH hooking is really efficient. It's really easy because we don't need to calculate the instruction size. We don't need to embed a disassembler. We just need to patch the first byte of the instruction with an opcode that will cause an exception that we can catch after. So for example, we can patch with the opcode CC, and so we will install an exception handler and catch that exception. And so every time the opcode CC is executed, our handler will execute our own code. So at that time, we can like modify the registers and patch all the data we need, okay? So yeah, we are glad like we can finally like convert the worms. We can hijack the loading of whatever assets. So we use the game, we execute Street Fighter Collection, and results, there's a black screen. So say shit. We have to dig more. It's not so easy. So actually what we did is there is a class for each different game, okay? We are able to reverse all the methods, and there is a method that is called loadROM. Actually, if we take the method loadROM from 2 different games, you can see that there is only one element that changed. There is a function that we rename setup CPS1 with ROM information that will set up the emulator with the information from the specific game. And actually, all the information from the game are given in the second argument. Here, RDX, I don't know if you can see well. So, for example, if we take the structure for Street Fighter II Champion Edition, well, it's kind of easy. We can see like there are the names of the game, there are all the name of the assets, and there are 2 pointers. If we check at the first pointer, it's all that are the deep switches. Actually, what is the deep switches? The deep switches are settings used to modify something in the game. So you can change the difficulty, you can change the free play, etc., etc. For example, for the game, there is an option mode where we can change only a subset of the deep switches. So Street Fighter let us only change the difficulty. And to be sure that it was actually the deep switches, we changed the game mode for test, and actually it was working. So the first case is solved. The second case was a bit more complicated. That is the second pointer, that structure, and we see a lot of dword values and an address here, and we don't know what is that. So we have to dig more. Actually, a set of these data are copied in the object attributes, and the first dword value is used in a method of the class mu_cps1. And if we do the reverse of that method, it's an emulator that is used to execute the ROM, the code ROM, okay? And it takes as argument the ROM and that value. And actually, that value, if you convert in decimal, it's 12 millions, it's 12 megahertz. Actually, we know that the processor Motorola 68,000 used for that game runs at 12 megahertz. Okay, so we know that in that structure, the elements will be specific at each game. For CPS1, for the original arcade board, there are a lot of registers. So for example, there is a register called priority mask. If you have two sprites exactly at the same place, they will tell you like, okay, you have to only show that sprite, okay? Luckily, if you look at the Mame source code, there is a lot of values, like all these registers value are documented. If we look at Street Fighter II Champion Edition, we can see that it used that data, and that data contains all these values. And the good thing is it's match actually, like the 1, 6, etc. are indexes into an array, and all these values are the values that were documented in Mame. So okay, we know that we'll have to patch these values for our games. The second element was that direction, that address. We didn't know what was about. So if we take a look at that, there are a lot of dword values. It was like, what the fuck is that again? Actually, there are data for JFX mapper. If we take a look at the source code, JFX mapper is just like something that will tell you, okay, that part of the graphics we have to to map in that part of memory, in that bank of memory, okay? And now, if you look well, you can see that it makes sense. I don't know if it's easy to see. Yeah. So for example, the first field, JFX type sprites, it begins at 0, and it finishes at 7FFFF, okay? The first field is 0, after 7FFF. After there is 0, 7FFF again. Actually, that is the start of the bank and the end of the bank. To be sure of that, we can see the JFX, the last sprites that begins at bank 2. The last sprite is here, like 10,000, it finishes at 11FFF. And if you can see the bank 2, it begins at 10,000 and finishes at 7FFF. So we know now the structure. And actually, there is an end marker here, -1, to say that, okay, that is the end of the sprites. After it begins with scroll 1, end marker, scroll 2, etc., etc. So when we figure how it's structured, we can finally patch also these data. So to summarize, to load an additional game, we have to convert the ROMs, we have to hijack the ROMs loading, we have to patch the CPSB data, patch the graphics mapper values, and now we can show you a demo. Yeah. There is sound. La bonne connexion. Yeah. No. Ouais. Oops. Okay.
¿Necesitas el sonido? It's okay.
No, no importa. Okay. So that's its normal behavior. When you play the game, you want to play Street Fighter 2 Hyper Fighting, okay, the game runs. Now we will apply like all the patches. We want to convert the game MS Word to Mu. So we use our Python script. It will convert the worms. We copy the worms in the worms directory. Okay, all the logic, like the code, like the hijacking code, the patching, etc., we've wrote it in a DLL that is called Mu hijack DLL, okay? So we copy Mu hijack in the folder of the game, Street Fighter Anniversary Collection, and we use CFF Explorer because what we want to do is to inject the DLL directly in the import directory table of the game. Like that, we'll be sure that our code will be run before the main game code, okay? So for that, with CFF, it's really easy. Like, just the only thing you have to do is in your DLL, you have to define an export name. That's it, even if there is nothing inside. Okay, and now we can run the Street Fighter. Yeah, it finds the new game that we put. Sin sonido, es un poco aburrido.
Yeah.
Pero bueno. So because we could hijack like whatever asset, we also hijack like we change the ROM logo, the game logo, and yeah, we can play. We also had to change the deep switches like to set free play, and yeah, we can play like, well, there is no sound. Normally there is sounds, but I don't know what happened. And the good thing also is we can change all the filters. It will work without problem. I forgot. Okay, there is specific ROM cases that are a bit more complicated. For example, Ghouls and Ghosts, there was no free play available, like with the deep switches. So what we can do if we really want to play that game? Well, actually, it's not so hard. We can patch directly the emulator game memory. So what we can do is we can use the Mame debugger because there is a cheat engine included. We can get the address of where are located the coins in memory. And after, if we reverse the 78,000 emulator from Street Collection, we can reverse an handler that is used actually just to read a word value from memory. So we can hijack that handler, and after just set some coins. So before the VRAM patching, we can see like the insert coins, and we cannot do nothing. And when we patch, well, there's a press start button.
This is because you don't have any button mapped to coin, so you cannot insert coins in any way.
Okay, so to load an additional game update, the other steps, it's either patch deep switches to set free play game mode or patch the game memory if free play is not available.
All right, so now we are going to talk about how to play these games online, because it's very boring to play against the CPU, and it's usually more fun to play against a human opponent. When the game was released, the 30th anniversary collection, for the game that I actually care, Super Street Fighter 2X, the online speed was incorrectly set. It was way quicker than it should be. Usually in other platforms that allow playing games online, like Fightcade, shameless plug, the speed that we set is Turbo 1 for the Japanese version, or Turbo Zero for the USA version or the world version. And this is because for the nature of online play, you get some latency, and sometimes you get some frame skipping on. So this balances the speed, and the equivalent of a Turbo Zero online is the Turbo 3 offline, more or less. So we wanted to play the game at the correct speed, so we thought that this could be patched, right? So this is the workflow when running an online game. It's very similar to the one that we have seen before, the loading an offline game, but it has an extra step, which is loading a save state. So what's the save state? The save state is just like when you play alone, you can save your progress and then continue from there. So if the CPU kills you, you can go back and continue from where you were. And for online mode, this is used to make sure that both parties are in sync. So they start actually with the same emulated machine state, same CPU register, same everything on memory, the same exactly on both sides. So Mu supports save states for the offline mode, and the 4 games that have online have their own save state saved locally. And these are embedded into the mbundle files. So we just create a new save state with the correct settings patched, with the correct turbo speed, and we, with the DLL hijacking that we have done, we just patch the save state when the online game loads, and we replace it with our modified save state with the correct speed. So this, we were able to fix this, but so you can see here it's playing. So these are actually a virtual machine running against the host. They are playing together, and it's running at Turbo 1, which is modified. This should be the correct speed setting for this game. And you follow from here? Yeah, so go ahead.
Okay. So when we are reversing like the netplay code, we saw something very interesting. Like in both, for both players, the ROMs are loaded locally for those players. So if we do exactly the same logic for offline, it might work. So what we have to do to enable netplay to play more games. So we have to do exactly the same as offline. And when we did the offline step, we play the game, we enable a second player, and we create a save state. We grab the save state from memory, we write it to a file, and then we hijack the save state loading with a new file. Okay? So a demo.
Here.
Okay. Okay, so we created a room, like just with a custom game, Final Fight, and we send like all the patched files to a friend from here, and he joins the room. Well, it's sad that there is no sound. And yeah, we can play like Final Fight online without problem. So the good thing is now we can just like use Street Fighter Collection to play whatever arcade games online or offline. And touch. Okay, so the source code is available. You can take a look at my GitHub. All is here, like the scripts, the C code, etc., etc. Questions?
Any questions?
Hello. The Z80 CPU was used for this song.
Sorry?
The Z80 CPU.
Yeah, for the sound.
Yeah.
Used for the audio.
Yeah, exactly. Yeah, it's the CPU for the audio. Actually, the audio works. It's just like on the computer. I don't know what happened, but you can just try the project. You will see everything works well.
Thanks.
More questions? Nope.
Here.
Nope.
So in the end, did you try running the ROMs that you extracted from Moo in Mame?
Yeah.
And that works?
Yeah.
Also with the graphics
Well,
fixed?
for CPS1, yes.
Okay.
For CPS2, need some fixes.
Okay, cool.
So tonight at 9 p.m., this guy and me are going to play on real arcade cabinets. We have a local tournament with the scene from here in Barcelona. If anyone plays the game and wants to join us, feel free to reach us and you can come.
Thank you.
Thanks.